time I'm going to email you 1 hour before class begin, whether I'm going to learn a class in the classroom or we have the online class at the time using the Wimba, that is the online class, the tool. You can go to the canvas, then find the conference, the menu, then I will send the detailed instruction how to join the online class in case school is not closed but the running class is online. If we do not receive any email, that means I'm going to have class in the class. Okay? Any question? I hope it will not be severe, but certainly it's bad here. Any question? So, the first half of the semester we are doing database design. We complete the first step of the database design. As we discussed many times, we have a bunch of information in our daily life. Okay, if you are asked to build a database system for your company or for your project or sometimes for your daily life, so your goal is to build a database system using DBMS. The computer. This is a computer. You are not going to build a database using your notepad. You are not going to build a database using your file organizer. Instead, you are going to build a database system using the software, that is the DBMS. Okay. In other words, the information sometimes is not well organized. Some of the information are organized, or if you, for example, you can use your file folder, and this one you can make the different file for different subjects. It's organized, right? So you can make such an organized data, but that cannot be to the DBMS. We need to follow the rule of such a DBMS to design to your database from information. The first step is we find entity and relationship that is called ER or extended ER modeling. Okay. This is called logical modeling or sometimes conceptual modeling. Okay. Still, we don't need any computer science, computer engineering, computer skill or knowledge to build the logical modeling. Instead, we need more knowledge on the data domain, information itself. Okay? Using modeling tool method that is called the ER modeling. It's a conceptual modeling, logical modeling. It can be used for the programming, it can be used for the different database like the hierarchical database. It can be used for any other computer. Or sometimes it can be used for the non-computer project. Okay? It's just organizing your information to do something conceptual model. Okay? How can we do that? We follow the step by step. First, we are going to identify entity. Eventually, we identify the entity type. Okay? And relationship, also attribute for each, and so on. Then we can have a very nice ER diagram. Okay, that is the first step. That is getting close to the database. Okay, but still there are huge gap between your ER model and your database system. Okay, in other words, the data structure used in DBMS is different from the ER model. So well organized is easy to understand the concept of your information, but still far from structured data. Okay? As we discussed a lot of time, DBMS is software. Okay? Which means this DBMS follows certain data structure, certain rules, certain constraint. When you are using the .NET or the ASP or the Visual Studio or C++, what does that mean? You are going to follow the rule used in that program or used in that program language. Since each language, each software has different data structure. Even though you are very good at the C++, sometimes a little bit struggle in using Java, okay? Because they are using different data structure. They are different. Just like when I speak in Korean, which is my mother tongue, you definitely cannot understand. Even though I am speaking the same meaning in different languages, you cannot understand because your protocol is different from mine. It's the same thing. So even though we organize the information like the diagram, but it's different from the DBMS database yet. I know, I understand. If you have the experience to build a very simple database, you skip this one, this one, this one, this one directly. Build a database. How? Because you are genius. Or because that is too simple. It's very simple, so you can directly build. But implicitly or intuitively, you already did such a process in between in your mind, even though you do not learn this one. But as I said, eventually we are going to build a very large database. If you have the small amount of data, which is not very complex, you don't have to learn the database modeling, database design. You can just create the database using SQL Server, then build your programming project. That's it. That's done. But that is a full programming project, not database. Okay? So the next step is we need to get close to the database structure, database model. Each and every software program, they have their own structure, they have their own model. In database, we are going to learn relational database model, which is adapted for relational database management system, such as Oracle, Informix, DB2, SQL Server, MySQL, but not NoSQL. That's different data structure. Like the MongoDB, have you ever heard about the MongoDB? That's not relational model. That's different database. CouchDB, Xander, they are different. We are not going to discuss about this one. Instead, we are going to learn the database model, database structure used in relational database management system, which is called relational database model, which is based on what? Concept of relation. Okay? That's the key part. How the data will be organized. Okay? So, in object-oriented model, as you have learned in your programming class, or the object, so is this still the 400, 390? What's the course number for object? 400. So you learned about something model, data model. At that time, how do you consider data? It's as an object. So your main job is to identify such an object from information. That's the different thing. So in relational model, we are going to find the relation first. Then, what is a relation? Who proposed the relational model first time? So Dr. E.F. Cole. When? So 1969, when Professor Lee was born, at the same time, that he proposed the idea of the relational model. The main problem when he proposed the relational model first time, The main problem was what? Very large data. When we managed the very large data, even though at the time internet was not used, there was a database management system. There was a database because most of the computer deal with the data. Okay? They deal with the data. Because of that, the size of amount of data is getting bigger, 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 and huge. So traditional computing architecture, the pointing data architecture cannot handle such a huge amount of data. Instead, we need the special model, special rules, special data structure to handle such a very large data. He realized when he check up all the data, sometimes you can find a common thing or characteristic. Like I have huge amount of file, which is for customer. He realized each customer can be represented by the customer name, customer ID, address, and so on. So we need a 5 information, 5 attributes to describe the specific customer. Also using customer ID or customer social security number, I can easily find, very fast find if data are organized. So from that idea, he realized, why don't we consider data as a group, not individually. In your program, why don't you think about your program? You probably used something, data in your programming also, integer I, or something, the object, or you consider data individually, separately, okay? Sometimes you can use an array, it has a multi-dimension. Anyway, you have the pointer of each data in the memory. Using that pointer, you can access the data. That is the waste of the resource, waste of the space. So, but all customer, each customer has the same structure. So why don't you consider all the customer, millions of customers as a group that it can be represented by the customer something. That customer is called relation. Okay? Relation is a group of data. Okay? Group of data. That's the main difference. That's the difference from all the data structure used in the program language. Or regardless of the type, like the object, hierarchical, they are different. In relational data, from the relation, since the relational database relational model, we regard the data as a group. Okay? If we access the data, it will return individual data. However, in relational model, if we access the data as a group, it will return group of data. It will return relation, not individual data. That makes the problem. That's different from other data structure like the program or object. Object return object. Or you can define object, the data type as an object, so it will return object, but the data relational model will return such a group of data, that is the relation. So group of data is called as the relation. Have you ever heard about the similar concept before? Group of, what is a group of elements? Set. Actually, the Dr. E.F. got the idea of the relational model from set, a set theory. Okay? So why don't we consider data as a set? Then it makes user access the data simple. It's so simple. Okay? And so, for example, when we have the lead, customer, and social security number, and address, and pattern, avenue, which park, city, and so on. So when we have the group of data, we consider group of data as a relation. After that, after he defined group of data as a relation, he realized that we can represent the group of data not only by the raw data. What if this is the name, this is the social security number, this is the address. All data has the same format, same information, same attribute. Why don't we represent the customer relation as group of attributes? So another definition of relation is a group of attributes. That means a relation. That means customer. Eventually, the concept of relation will be what? Later, it will be table. Okay? Have you ever heard of a table in the database? That is the same as the relation. That is the basic unit of the relational model. So there are two major ways to define the relation. One is group of data, or group of, sometimes it's called rows. Okay? It's the same meaning. Or sometimes group of tuples. This one is called tuple. Each row is tuple, a tuple. If you look up the dictionary, some of the dictionary does not have a tuple. Okay? It's used in computer science. Also, in addition, we can define the relation as a group of attributes or group of, this one is called color. So you may hear about the name of color where? Like the Excel spreadsheet. Spreadsheet is row by column style. Very simple data organizer. Okay? It's called the color. So this is the definition of the relation. Okay? That is for this one. We will see details more. What is actually the model? What is the definition of a model? Model means it's a rule. It's a protocol in terms of a network. It's a policy. It's a constraint. It's a condition. Who will define such a constraint? Who will define such a constraint? Who will define such a rule? Okay? So this is the basic rule of definition of the data, which is relation. This one is used for database model, for specific software. There is a still gap between this ER model and this relational model, right? They are not same, they are different. So we did this one, then we will learn today the relational model. There is a gap between ER model and relational model. But good news is they are quite similar. So we can convert, map from here to relational model. Then finally we can build the relational database management the database system using RDBMS. First, information, logical modeling, okay? Physical modeling, this is called the physical modeling. Conceptual modeling, physical modeling, low-level modeling, high-level modeling, okay? Then finally, create the database. That's the database design process. Okay. If we represent this one using the set theory, set concept, customer, it consists of what? Name, this is an element, ID, this by the row, this will be like one element. One element is lead and 111 address. Next element is matter 222 and so on. Next, if you have like this. However, we are not going to use this definition. Instead, we will see the notation of the relational model later. Any questions? Looks like easy, but sometimes a little bit confused. So what's the difference between ER model? Somebody already complained. I know this is a table. This is something. Yes, I understand. If you already learn about if you already have experience on the database, sometimes you can skip this part if your database is simple. However, we are dealing with very complex database model. At the time, you better follow such a designing process. Is that the only way to design the database system? No. This is just one example based on ER model and relational model. There are a bunch of other database modeling, like the network modeling, object-oriented model, even NoSQL database. That's huge difference from such a database model. Like the H-base, NoSQL means there's no schema actually. Unlike this. I'm thinking to offer such a NoSQL database for semester. So if you are interested in such a NoSQL database, you can take the course. It's a 600 level, but I do not ask the prerequisites. So anybody who has the hands-on database experience, then anybody can take. Okay. Actually, this is a side story. When after Dr. E.F. Code, when he proposed the idea of relational model, so he was in the IBM. So he was in the IBM T.J. Watson Center. It's still very, very famous for the data and database, the research. So after when he proposed the idea of the relational model, the main database architecture at the IBM was DB2. So hierarchical database and also DB2. So IBM decided at the time the relational model proposed by Dr. E.F. Code will not be very popular. Okay? Our current database architecture are enough. So they actually give up to commercialize. Then, including Dr. E.F. Code and his colleague, they quit the job and make the company, then try to commercialize the idea of relational model. Then version 1, version 2, version 3, finally version 6, they successfully launched the commercial DBMS system. Okay? Which is what? That is Oracle company. So Oracle, I think there was a version 5 even, version 6 it was I believe the first version to successfully announced to the market as a commercialized software. Then right now it's 12, version 12, which is called Oracle 12C. C is the cluster. I think the main idea, core part of the DBMS engine, Oracle DBMS engine, is 99% is the same as Oracle version 6. That's the reason I can still teach. I learned the Oracle database using the version 6, but the main architecture is not changed. They add additional feature, but it's not frequently used. The main part is still the same. Because it's based on the relational model, they cannot change it. until they change the database model into NoSQL database or hierarchical database, will not be changing. Okay. So, relation. What about the IBM? The IBM actually has their own database structure. It's a hierarchical database structure. But they realized after Oracle successfully launched the commercial software and everybody crazy to use the IBM announced, developed the DB2 for relational database. Then DB2 is not enough to compete with Oracle. They purchased, merged Informix also. So Informix is well known for the data warehousing system. It's very good for processing huge amount of sometimes column-based data. But still, it's way below the Oracle in terms of market share. And the first one is definitely the Oracle right now. And the Oracle is good for online transaction. Transaction module is very, very nice. Okay? It can support millions of the transaction with the help of the middleware, but it's very good. SQL Server is still struggling to get out of from Microsoft product. Okay? It doesn't work very well with others, but it's good for Microsoft family, like the Visual Studio or the .NET. It's very easy without any knowledge on the database. You can just code the database library or component. Then you can consider database as an object or component. Okay? So that's the benefit, the advantage and disadvantage of using SQL Server. What about DB2? DB2 works for the medium-sized server or smaller. Okay? While the Oracle is good for the mega size of the system, huge size of system, including cluster. Okay. Okay. So this is the definition of the relation. Okay. In terms of the ER model, it's an entity or relationship. Okay, we will see to map the real world ER model and relational model, how to bridge it. Okay, how to map next class on Thursday. So, formal definition. That is an informal definition. This is a formal definition. Before that, what is formal means? What does formal means? What does informal means? Formal means neat. Neat. Good word. The informal means the bad word. Order. Special. So informal means not special. Standardized. So which means the informal means it's not standardized? Yes, I think so. It's getting close. Formal in computer science, when we are saying formal something, formal definition, formal processing, formal means mathematics. Always. Okay? So mathematics. Why? Mathematics is the kind of language of what? Nature. Whether or not you can see. What about the Pythagorean theorem? Do you think the Pythagorean theorem is true? In universe, develops? Yes. That's the benefit of using math. Even though the alien used a different terminology or different name of the Pythagorean theorem, it's true in any planet, right? But if I'm saying, if triangle, if the square, so it's very hard to explain, but anyway, so you can explain the Pythagorean theorem in English or in your language to your cousin or 10 years old, your son or daughter, you can explain. That is the informal way. However, informal way cannot cover general case. Informal way is usually easy to understand. But it's a case by case. Like the right? You can prove this one. If you are taking the math course from sophomore or the freshman, you can prove it. How can you explain to you? Your son does not like the math. You need to times 1 times 0, 0. 2 times 0. Any number times 0 will be 0. That is the informal way. But if you can prove that this one, that is a formal way. Okay, so we'd like to use such a mathematical term to define the relational model. As I said, Dr. E.F. Coe employed the idea of what? Set theory in math to define the relational model. So, relation R is defined as a group of attributes. Attribute is the A1 through AN. It's not limited, it's a limited number n. If we have number of attributes, we can define the relation R. For example, customer ID, customer name, address, and phone number. So, in general, we can say relation is a group of attributes, A1 through AN. Also, each attribute, where can you get the each attribute? What is attribute anyway? In ER model, attribute is description. It's an informal way. Okay, just a description. What about the formal definition? What is the attribute? Color? What is a color? At that time, we are going to use domain. Domain is kind of a jar. But this jar, my jar, has all the information or data that has the common structure. For example, I have phone number domain. It has all the phone number. So what is a phone number? In US, 333, not 3 digit of area code, then 3 number and 4 number, followed by 4 number. This is the phone number. It's very hard to say this is a format. Anyway, this is a US phone number format. So my jar has all phone number in United States. That is the domain of what? Phone number domain. What about the customer name? Customer name is a domain. So my domain, my jar for customer has all name in the world in my jar. All name. Okay, it will be huge. But anyway, it's a concept. That is the domain. What is the similar concept of domain? Data used in your programming. Okay, data type. However, what's the difference between domain and data type? Domain is keep the all data, all inject. Okay, while data type is more strict data structure. Okay, for example, character. So, for example, number 9 digit. Number 9 clearly define the number 9 only for data type or phone number. So usually domain is the superset of data type. Okay. Also, data type is close to computers. data structure, computer. What about domain? Domain you can implement in the computer, but it needs a lot of research because you need to keep all the name of what? Customer. That makes sense. We can do that. Anyway, we have a limited number of the people, but what about the future? It's very, very hard. So when Dr. E.F. proposed his idea of the relational model, he used the domain. So this one is from the domain of A1. This one is the domain from the A2. But when he implement the relational database concept, he adapted the idea of data type. However, there are still the relational database management system that utilize the concept of domain. Okay? Because data type is too strict and too close to the computer. Sometimes you lose the meaning of the domain. For example, in this, there are 3 groups and 3 numbers, there is a specific meaning. When you define the phone number as the number 9, you lose such an information. Okay? Instead, you need to add more constraints to keep such a thing. First, the 3 digits represent the area code, something like that. You need an additional database. That is the data domain. So it's from the data domain. So we can define relation R as a group of attributes. Also, how can we define the relation? It's a group of attributes, group of data, right? How can we represent a group of data? We can pick up one value from A1, domain, A1. One value from A2, domain of A2. And so on, domain of A and their combination. Or combination of domain of A1 to AN will be relation. It's a simple data. For example, in this case, we have 3 jars. One is the name jar, name domain. Another one is social security jar. This jar has all social security number. This one has the address jar, domain. Then pick up the among bunch of the name, pick up this one. Then social security number. Huge number of among the huge number of social security number, pick up this one. Same thing, address, that is the one data. Then, so we can generalize such an idea by the, what does it mean, X? It's a product. It's not multiplication, it's a product. Have you ever learned about such operation, product? Kin is from math. Cartesian product. What is a Cartesian product? You do not remember Cartesian product? Probably you learned. Why don't you back to your elementary school sometimes? Depends on level of your curriculum in your country or in your state. You probably learn in this book. What is a product of B? You learn this, right? This is an all combination of this. B2, B3. Same thing. Okay? So, A is what? Domain of A. A attribute. B is domain of B. Approximately Domain of A has only 2 data. Domain of B has 3 data. So we can make the tuple. This is 1 row. 2, 3, 4, 5, 6 row. We can make all combination. That's called Cartesian product. That relation is the subset of that Cartesian product, which is the definition of relation. Okay? So your head is boiling. You learned about the concept of the set theory in your elementary maths. That's the same. So this is a formal definition of relation concept. At this time, capital R usually represents name of relation, while lowercase represent each tuple, each data. Okay? So at that time, R is called, if you increase the number of attributes, that is called intension. If you increase the number of data, that is called extension of relation. Okay? Our goal is first to define intention, attribute in the design. Later, we insert the data, sample data, real data, that is called extension. That will be what? Database state. What is a database state? Go back to the first week of this class. Database schema plus sample data. Database schema, intention, database, the data, that is extension. It's a database state. Okay? Any questions? So tuple is an ordered value. When after he has proposed, the tuple is defined as an ordered set. Why? It's called ordered or non-ordered. What's the difference? Actually, set theory is the most fundamental subject of math. What is math? Plus minus. Just piece of math. If I ask the same question to the elementary or most of the K-12, the student, they will answer some kind of number. Right? So what is a number? Yes, that's true. Math there is the number. What is a number? So you learn the natural number, real number, rational number, and even the imaginary number, right? Then number, one of the main problems, main obstacle to learn the number is what? It's infinite, right? How can you say A plus B is equal to B plus A? Did you check all the numbers? It's not possible. How can God? How can you? First, we need to define what is a number. So, number 1 to 3 is natural number set. Real number, even though we do not represent, real number can be defined as a set. We start from such a set by defining the number, unit. Then you can do operation, one algorithm, like you can build your own algorithm, networking algorithm, bunch of things. First start from the set. In this case, this is an ordered set, which means there is an order 1, next 2, 3. 3 cannot be bigger than 2. This is called ordered set. In this case, ordered set of value means there is an order, like the 632895, followed by John Smith's value from the name domain, and 101 Main Street, Atlanta, Georgia, then so on. However, in real application later, when you build a database, that order is not important. Okay? So you don't have to pay attention too much for order or non-order. Also, this tuple is considered as rows. Okay, then you can easily understand. I already explained about the domain. So don't be confused with the domain with the data type. They are different things, but practically we use data type. So in other words, when you design the database, our goal is to find such a set of attributes, but also you need to define what will be the domain or what is the data type of this. Mainly we have character and number, right? But there are more, so we will see it later. This is an example of the domain. We have two domains of attribute. S1 attribute, S2 attribute, 0, 1, ABC. So this is the example of relation based on this domain. Okay. What about 2A? 2A is not a proper element or proper tuple. It's not possible. It is what should belong to Cartesian product of S1 and S2. 2 is not in this domain. So this slide shows the definition, summary of the definition, informal way and formal way. As I said, formal way means used in mathematics. In other words, it is used for paper. So for example, I have a new idea of the database model. So how can you prove? You need to prove your idea by defining the relation, attribute, then publish to others in the conference. Then if reviewer, everybody agree your idea is good, then it will be accepted. At that time, if you are using the informal term, it doesn't look like the correct, because it's not used in the mathematics. So at that time, you better use a formal terminology. But practically, for example, when you join the project or company, sometimes informal terminology used frequently. So either way is fine. However, if you are in the academia, okay, you better use formal. For example, when I read the first time the published paper from IEEE regarding to the database, there are a lot of tuple. At the time, I didn't understand what is a tuple. Why they do not use the row? I couldn't understand at that time. But that's true. If you read the technical paper published in the conference or journal, they use the tuple instead of row. Okay? Also, it doesn't look like the professional if you use the informal terminology. Okay. So this is an example of the relation that we define. We have the student what? Relation. Not table yet, but as we have seen here, the relation eventually will be table in DBMS. Okay? You better know the comparison table, summary table. Anyway, so this is a student relation. What student? Table. So we'd like to define the student relation by attribute. Name, social security number, home phone address, office phone number, age, and GPA. That is student. We can define such a way, a group of attributes. Or we can pick up one value from main domain, one value from SSM, and so on, then make the group of data, group of row. This is the tuple. Who are rows? Data. That is also student. Okay? Can you understand this one? Except one thing. What? What is this? Is it real data, NULL? However, when you check the home on domain, there's no data like the NULL, but it's in here. What does that mean? Can you remember this symbol? This is an empty set. So probably you got this kind of question. Which one is different from the others? Number 3. This is a set, right? It's not an empty set. This is a set including this kind of element. However,